Watch as a gleaming propeller airplane cuts through golden clouds at sunrise, its blades spinning in hypnotic slow motion. How can this simple rotating device lift thousands of pounds into the sky? The answer lies in a fascinating journey from raw metal to controlled flight, combining precision engineering with the elegant laws of physics. Every airplane begins as an idea on a computer screen. Engineers spend months designing every component using advanced software, calculating precise aerodynamics, load distributions, and structural stresses. They determine optimal wing shape, fuselage length, engine power requirements, and propeller diameter. Each line represents thousands of calculations ensuring safety and performance. Inside a sprawling aircraft factory, the transformation begins. High-grade aluminum alloy sheets arrive alongside composite materials specifically chosen for their strength-to-weight ratio. Robotic CNC machines cut with millimeter precision, drilling thousands of holes for rivets. Sparks fly as metal takes shape, each component manufactured to exacting tolerances that allow no margin for error. The wings are the airplane's most critical component, requiring meticulous assembly. Technicians carefully install internal aluminum ribs and carbon fiber spars that form the structural skeleton. Control surfaces are precisely hinged, fuel tanks sealed and tested, then lightweight skin panels are riveted over the frame. Every connection point undergoes rigorous inspection before approval. The heart of any propeller aircraft is its piston engine. Skilled mechanics assemble aluminum cylinders around precisely machined pistons. The crankshaft connects each piston, converting their linear motion into rotational power. Intake and exhaust valves are timed perfectly, spark plugs positioned for optimal ignition, and cooling fins added to dissipate tremendous heat during operation. The propeller itself is a marvel of engineering. Each blade is essentially a rotating wing, carved from solid aluminum or composite materials. Computer-controlled machines shape the complex curves and twisted geometry. The blade's cross-section forms an airfoil carefully designed to accelerate air backward efficiently. Even minor imperfections could cause dangerous vibrations at high speeds. Now comes final assembly, where individual components unite into a complete aircraft. The fuselage receives its wings, bolted through massive attachment points. Landing gear struts are installed and tested for strength. The engine is carefully mounted to the firewall, propeller hub attached, and cockpit instruments wired. Every system undergoes multiple safety verification checks. Understanding how it works requires looking inside. The engine's pistons fire in sequence, driving the crankshaft into rotation. This rotational energy transfers directly through the propeller shaft. The propeller hub may include reduction gearing to optimize blade speed. Everything synchronizes perfectly, converting controlled explosions of fuel into smooth, continuous rotational power that spins the propeller. As the propeller spins, magic happens in the air itself. Each blade cuts through space like a rotating wing, its curved surface accelerating air molecules backward at high velocity. This creates thrust, pushing the airplane forward according to Newton's third law. The faster the propeller spins, the more air it moves, generating greater forward thrust to overcome drag. But thrust alone doesn't create flight. As the airplane accelerates down the runway, air rushes over the curved upper wing surfaces faster than the flatter lower surfaces. This speed difference creates lower pressure above the wing compared to below, generating upward lift force. When lift exceeds the airplane's weight, flight becomes possible. Pilot advances the throttle. The engine roars to life, propeller becoming an invisible disk of motion. The aircraft rolls forward, accelerating down the center line. Faster, faster, until the wings generate sufficient lift. The pilot gently pulls back on the control yoke. The nose rises and the wheels lift off. The airplane climbs gracefully skyward. Once airborne, the pilot manages 4 fundamental forces acting on the aircraft. Lift from the wings opposes gravity's downward weight. Thrust from the propeller overcomes aerodynamic drag. By adjusting throttle, control surfaces, and pitch attitude, the pilot maintains perfect equilibrium. This delicate balance transforms powered motion into sustained, controlled flight through 3-dimensional space. The airplane cruises effortlessly above stunning terrain, propeller maintaining constant speed, engine humming reliably. Inside the cockpit, instruments display altitude, airspeed, and engine performance. The pilot scans the horizon, feeling the subtle vibrations of power transmitted through the entire airframe. This is the culmination of countless engineering hours and manufacturing precision working in perfect harmony. From bare aluminum sheets to controlled flight through the atmosphere, the propeller airplane represents human ingenuity at its finest. Engineers calculated, machinists crafted, assemblers united, and physics enabled what once seemed impossible. Every component serves its purpose, every force finds its balance, and a machine heavier than air dances among the clouds. The next time you see a propeller airplane overhead, remember the remarkable journey behind that simple spinning disc. From precision engineering to physical laws perfectly applied, it's a testament to human innovation. That elegant rotation doesn't just move air, it moves dreams, connects destinations, and proves that with understanding and craftsmanship, we can indeed conquer the sky.